Hello, everyone. So for this session, we will be talking all about the law of conservation of momentum. So allow me to present my presentation or my yeah. So we have here a scenario where there are two cases. The first one is the cannon, which is before the firing of the cannon, and then for number two, that is after firing the cannonball. So we have two questions here. The first question is, what is the momentum before firing? So if your answer is zero, you are correct. Because just like what we discussed in the previous sessions, that there is no momentum if there is no movement at all. So the answer to this question is zero. But the second question is, what is the net momentum after firing? And if your answer to this question is also zero, then you are correct. But the question here is why? Remember that the momentum before firing is zero because the velocity is also zero. After the firing, although there is momentum, I mean there is velocity, after firing the net momentum is still equal to zero because the momentum of the cannonball is equal to the opposite of the momentum of the cannon. So the cannon and the cannonball itself, they have the same amount of momentum, but they are opposite. That's why if you add them, that will be equal to zero. Now, what is happening here? In this scenario, we have here that the force or impulse that changes momentum must be exerted on the object by something outside of the object or outside of the system. In this case, there's no external force. Why? Because the force that are included here are the force within the cannon and the cannonball system alone. No? Wala siya gituklod, wala siya gibira. There's no additional forces outside of the system. So in this case, the force on the cannonball inside the cannon barrel is equal and opposite to the force causing the cannon to recoil. The reaction and the action forces are internal to the system, so they don't change the momentum of the cannon and the cannonball system. Now this is under what we mean by the law of conservation of momentum. Now, in physics, anything that does not change, we call this as conserved. So when you say law of conservation of mass, ibig sabihin, there's no change in mass. Law of conservation of energy, ibig sabihin, there's no change in energy. So same siya sa ato ang law of conservation of momentum. That means there's no change in the momentum from the first and the second scenario. So it is a system, or if a system undergoes changes wherein all forces are internal, the net momentum of the system before and after the event is the same. That means they're the same, and if they're the same and they're opposite, so that will just be equal to zero. So what are the examples of this phenomenon? So we have atomic nuclei undergoing radioactive decay, cars colliding, or stars exploding. Now, to be able for us to really understand the concept of the law of conservation of momentum, let's apply that to the types of collisions. So basically, we have three main types of collisions. We have elastic, inelastic, and perfectly inelastic. So collision of objects clearly shows the conservation of momentum, where the net or the sum of all of the momenta before the collision is equal to the net momentum after the collision. So we have here elastic collision. Elastic collision is when objects collide without being permanently deformed and without generating heat during the collision. So if ever they hit each other, wala deform, ingana no? So um the best example of that is bowling. When you play bowling, or when you play bowling and billiards, okay? So when you play bowling and billiards, even though the balls are really hitting with each other, so there's no deformation happening. So that's under elastic collision. The opposite of that is called inelastic collision, where it is a collision in which the colliding objects become distorted and generate heat during the collision. Just like what you see here on the screen, the picture of two cars hitting with each other. So that is an example of inelastic collision. But in reality, the elastic collision is very hard to achieve because even if, like example, even if you play bowling or billiards, there is always sound that is produced. There is always heat that is somehow, even though it's not very observable, but there is a slight change. So elastic collision is not really 100% met here on Earth. So to really classify or to really differentiate the two types of collisions, in the elastic collision, the total kinetic energy is conserved. Ibig sabihin, the kinetic energy before and after they're the same. While in the inelastic collision, the total kinetic energy of the body at the beginning and at the end of the collision is different. Why? Because it was clearly emphasized a while ago that in elastic collision, there is a change of the energy na. It could be the pagbangga nila, nagproduce siya og heat, nagproduce siya og sound. So there is a change in the amount of energy
Next,
anymore. Even though they are different in terms of the type of collision, is still momentum is conserved. And there is no conversion of energy taking place in elastic while there is in inelastic. Just like what I said a while ago, it could be a sound or heat, no, sa pagbangga nila. Next, elastic collision, it is highly unlikely in the real world as there is almost always a change in energy. Just like what I said a while ago, the best examples when you play volleyball, when you play bowling or billiards, even though they are not observable, it is not observable na there is some changes or distortion, there is always some production of heat and sound. So although under siya sa elastic collision, it's not 100% elastic collision. Okay? So here, in elastic collision, this is the formal form of collision in the real world. Remember that even though magbangga na sila dinha ano, there is always exemption to this. First, when you have billiard balls, they encounter friction with the table and in the air. So strictly speaking, it is not 100% elastic collision. But we try to put it under that way so that it will be easier for us to understand these things. Next, after a collision of two trucks, the combined wreck slides along the pavement and friction decreases its momentum. Remember that we're talking all about the conservation of momentum. So basically, when we focus on this idea, we give importance to the idea that there is no change in the momentum. But that is not happening in the real world. Why? Because if ever na magbangga duha ka buok cars, for example, there is always friction sa brakes, friction sa pavement, friction sa agianan or whatever. And that decreases the momentum before pa sila nag-hit. Okay? And the last one is two space vehicles docking in orbit have the same net momentum just before and just after contact. Since there is no air resistance in space, the combined momentum is then changed only by gravity. So this is only applicable for those nga naa sa outer space. Okay? So these are some effects of external forces in the collision. So, now, we have here the illustration of how elastic collision works. Remember that this is, ano, in Bisaya, when you say elastic collision, wala sila, nagbangga sila, after nila nagbangga, nagbulag gihapon sila. No? Mo na ibuot lang ko to pasabot sa elastic collision. They do not have the same, they have different velocities. Okay? So in this case, makita ninyo, before collision, it could be that this white here is not moving. So during the collision, this is what's happening. But after the collision, when you try to check, they do not stick with each other. They have different velocities. So when you try to put it in mathematical way, we have here the mass of the object A times the velocity of the object A sub 1. That means before the collision plus the mass of the object B times the velocity of the object B before the collision. Remember, this is momentum, okay? For a while. So this is the momentum of the mass A, let's say the red ball. And this is the momentum of the mass B, which is the white ball. So when you try to add that, that would just be equal to the momentum of the mass A plus the momentum of the mass B after the collision. So this is the general expression for the elastic collision. So later on, when you visit other stations, there is a tutorial there on how to answer problems related to elastic collision. Next, this is the expression on inelastic collision. So when you try to check, when you try to compare, kagain na, in Bisaya, no, ang elastic collision, after sila nagbangga, nagbulag yapon sila. They have different velocities. Pero sa inelastic collision, after sila nagbangga, nagdikit sila, and they have the same velocity. Example, if you try to throw a mud in the wall. So ang mud nipilit siya sa wall, wala siya ni baylo. In here pod pwede nga there are two cars or vehicles nga unsa man duha ka vehicles nga nag-meet or nagbangga and they are moving as one na here. They have the same velocity. So nagdikit na sila. They have the same velocity na. Okay? So, the same gyapon natong expression, this is the momentum of the first body plus the momentum of the second body equals the momentum of both. Remember that they have now one common velocity. So, ibig sabihin, we simply add the mass of the first and the second body multiplied by the velocity of them. Kasi nga, isa raman ang ilahang velocity. They are as one. So, those are the basic or the common ideas on the types of collision and the law of conservation of momentum. So you may check other videos or my other videos for the tutorial on how to answer problems related to elastic and inelastic collisions.